Okay, let's talk about modern AI. I mean, it can feel like straight up magic, right? One minute it's writing a poem, the next it's creating this incredible image from just a few words. But what's really going on under the hood? Let's pull back the curtain.
So, this is a big question. How in the world can one single program do all of that? A poet, an artist, and a computer programmer all rolled into one. I mean, that just feels like it shouldn't be possible. But the answer isn't magic. It's a revolutionary new type of AI that has changed the game completely.
And that revolutionary idea is the foundation model. You can think of it as the engine, the secret sauce that's powering pretty much all the mind-blowing AI you're seeing today. So here's the key insight. Foundation models are not specialists. They're extreme generalists. They're trained on a simply mind-boggling amount of data. Texts, images, code, basically absorbing the patterns of the entire internet. This creates an incredibly powerful and flexible base that you can then easily adapt or fine-tune for hundreds of different specific jobs. So what makes these things tick? Well, first, just their massive scale. We're talking billions of parameters, which are kind of like digital knobs the AI can tune. They learn using self-supervision, which is a fancy way of saying they teach themselves by finding patterns. No human labeling needed. This scale leads to something truly wild: emergent capabilities. New skills that just appear, things they weren't programmed to do. And this all runs on something called the transformer architecture, which is a breakthrough way of understanding context. It's the whole package that gives them their incredible adaptability.
All right, so we know what they are, but what's actually happening in that so-called digital mind when you ask it a question? How does a simple string of words turn into a complex, coherent answer? Let's follow the journey.
It's really a four-step dance. First, your question gets broken down into little numerical pieces called tokens. Then, the attention mechanism kicks in, weighing which of those pieces are most important to the meaning. From there, it's all about pattern matching. The AI scours all the data it was trained on for similar structures. And finally, it starts generating a response by predicting the next most likely token, then the next, then the next. And that's the key here. It's a super sophisticated prediction machine, not a thinking one. But these models do have a critical limit, and it's called context length. The easiest way to wrap your head around this is to think of it as the AI's short-term memory. It's the maximum number of tokens, from both your prompt and its own response, that it can hold in its attention at any one time. And this is where things get absolutely wild. Just look at this timeline. In only 6 years, the AI's memory has just exploded. Back in 2018, a top model could maybe remember a few paragraphs. Now, in 2024, we have models that can process over 1 million tokens. That's like feeding it the entire Lord of the Rings trilogy at once. This isn't just a small step up. It's a world-changing leap that unlocks completely new possibilities. All of this massive scale has led to something genuinely strange and fascinating: emergent behavior. You see, as these models get bigger, they don't just get better at the tasks they already know, they spontaneously develop brand new skills. Things like multi-step reasoning or writing computer code. These weren't programmed in. They just emerged. It's one of the biggest marvels and mysteries in AI today. But as you've probably guessed, this kind of incredible power doesn't come for free. It has some very real and often very hidden costs that we absolutely need to talk about. Let's start with the environmental impact. Those massive data centers that power AI get incredibly hot, so they need constant cooling. And that cooling takes a shocking amount of fresh water. How much? Well, training just one large AI model can slurp up 700,000 liters. That's enough water to fill a big backyard swimming pool more than 10 times over. And it's not just water. The electricity required is just immense. The carbon footprint from training one of these giant models can be the same as the yearly emissions of 125 gas-powered cars. That's the huge energy cost hiding behind that simple little chat box. So beyond the environmental costs, there's a serious reliability issue.
Because an AI is just a pattern-matching machine, it can sometimes produce answers that sound perfectly confident and plausible, but are actually completely wrong or just nonsense. This is called a hallucination, and it's a major challenge because the AI doesn't even know it's making things up. And then there's the data itself. To learn, these models are fed information, vast quantities of it, often just scraped from the public internet without anyone's permission. This opens up a huge can of worms around privacy, data breaches, and, really importantly, algorithmic bias. If the data it learns from is biased, well, the AI is going to be biased too.
Now, these are some significant challenges, for sure. But here's the good news. They're not going unnoticed. Researchers are already hard at work developing smarter, more efficient ways to build AI. Let's look at the solutions that are paving the way forward.
A really key strategy is to move away from this bigger is always better mindset. So instead of using one giant, energy-hungry model for everything, developers are building smaller, specialized models trained to do just one thing very well. And the result? They can often do the job just as well, but with up to a 90% reduction in their environmental impact. That's a huge win.
Another really clever approach is this architecture called a mixture of experts, or MOE for short. Now think of it like this. Instead of one giant brain doing all the work for every task, an MOE model has a whole team of specialists on standby. A smart router looks at your request and sends it only to the specific expert network that's best for the job. And the difference in efficiency is just staggering. A traditional model has to fire up its entire massive network for every single query. It's incredibly wasteful. An MOE model, though, only activates the small fraction of experts it actually needs at that moment. This means you can get state-of-the-art performance for a fraction of the computational and environmental cost. It's just smarter.
And finally, the rise of open-source AI is a complete game changer. By making the code public, the community can foster real transparency. Anyone can look under the hood to inspect for bias or security flaws. It gives people control to customize models for their own specific needs, which protects privacy and drives innovation much faster.
So, where does all of this leave us? What does the future actually look like as we learn to live and work alongside this incredible and complicated technology? Well, as AI expert Thorsten Meyer points out, the path forward is all about balance. We need to embrace the truly unprecedented power that AI brings to the table, but at the same time, we have to stay clear-eyed about its very real limitations and challenges. And ultimately, I think this is the real goal. Progress isn't just about building smarter and smarter AI. It's about us fostering a smarter human-AI partnership. It's on us to learn how to use these powerful new tools effectively, ethically, and responsibly. And that really leaves us with the final, most crucial question. AI is evolving at a breathtaking pace, there's no doubt about that. But the most important question isn't, what will it do next? It's, how will we choose to evolve right along with it?